As of today, most of the world is using IP version 4 or IPv4 for short. And I mention that because there's also an IP version 6 or IPv6, which is a newer version that behaves a little bit differently, but since IPv4 is still widely used today, let's go ahead and start there. And let's use this IP address of 172.16.1.10 as an example. IPv4 addresses are 32 bits long, divided in 4 parts, 8 bits each, called octets. But what does this mean? Well, as you can see, it's divided in 4 parts, each one separated by a dot. This IP is in what is called decimal format, which means it uses numbers with base 10, which is a simple way of saying that it uses a combination of numbers from 0 to 9. So let's analyze the first octet of 172 since this applies to the rest of them. Looking at this table, we start by counting from right to left, starting with multiplying by 1, but since this is base 10, we multiply by 10 as we move to the left, which means we end up with times 1, times 10, and times 100. And since we're taking the number 172, we are multiplying 2 by 1, which is 2, 7 by 10, which is 70, and then 1 by 100, which is 100. And if we add 100 plus 70 plus 2, then we have 172. But there is an issue with this. Computers work in binary, not decimal format, meaning they don't use base 10, they use base 2, which is a combination of two numbers from 0 to 1. So let's look at how we can convert from binary back to our decimal notation by using the same octet of 172. We can use the same table, but since this is base 2, we multiply by 2 instead of by 10 each time that we go to the left. And like we said before, each octet has 8 bits, meaning 8 positions for each number. So we have 8 different columns in this table, starting from times 1 all the way to times 128. So in this case, we'll use a 1 in the bits positions that we need, and then a 0 in the bit positions that we don't need. Now, in order to know which positions get a 1 and which positions get a 0, we'd have to do decimal to binary conversions from 172 to its binary notation. But that's even more math than we need, and there's so many calculators online that can do this for you that I won't show you that here. But if you'd like to learn more about that, feel free to research it and or ask us in the forums on cyber.com or even on Discord, and we'll be happy to help. But let's go ahead and pull up a handy calculator and let's convert 172 from decimal to binary. And we get 101,01100. So now our table looks like this. We take the values that are multiplied by 1, since those multiplied by 0 would be equal to 0, which means that we're left with 1 times 4, which is 4, 1 times 8, which is 8, 1 times 32, which is 32, and then 1 times 128, which is 128. And if we do 128 plus 32 plus 8 plus 4, we are back at 172. So we're back at our decimal of 172 for the first octet of our IP address from that binary 101,01100. Now, by running through these examples, we get to see the conversions that are happening super fast since computers think and view information differently than we do. Now, luckily, technology nowadays has abstracted a lot of that away from us, which makes it a lot easier to set up networks and which requires a lot less math. But with that said, it is important to at least understand what's going on behind the scenes. So let's try one more octet before we move on. The second octet in my IP is number 16. So 16 converted to binary is 10000, which is 5 different digits. But since our table contains 8 columns to represent 8 bits, we can pad the front with zeros. And so we're left with 0001000. So this one's really easy. We only have 1 times 16, which is equal to 16. So we can confirm that this binary notation does equal the decimal notation of 16. So that's a really quick look at how IP addresses are translated to and from binary format and decimal format so that we as humans can more easily read them, but so that computers can also still do their jobs. Now, as you're ready to move on, go ahead and complete this lesson, and I'll see you in the next, where we'll discuss network masks.